Hello dear students, good morning. We'll start with the first unit, that is flow around submerged bodies or objects. Introduction. In various engineering fields, we encounter with the problems which involve the flow of fluid around submerged bodies or objects. In such problems, either a fluid may be flowing around a stationary submerged body, or a body may be flowing through a large mass of stationary fluid, or both the body and the fluid may be in motion. That means to say, always there will be a force exerted on the body with respect to their relative motion. In the sense, body may be in motion, fluid is at rest, or fluid is in motion, body is at rest, or both are moving. A body immersed in a fluid experiences a resultant force due to the interaction between the body and the fluid surrounding. There may be three cases of fluid past submerged body. Body is at rest and fluid is flowing. Fluid is at rest and body moving through static fluid. Both body and fluid moving with certain velocities. Examples, you can see the figures also here. The body is stationary and the fluid flows past the body with velocity u, meters per second. In this case, fluid exerts force on the body as fluid resistance. Similarly, according to Newton's second law, body also exerts equal and opposite force on the fluid. This phenomenon takes place due to the velocity difference between fluid and object. Second, fluid is at rest and body moving through static fluid. The fluid is stationary and the body moves through the fluid with velocity u meters per second. In this case also, body experiences a force exerted by fluid on the body as fluid resistance. Therefore, in both the cases, the magnitude of the force is same. It is unchanged. Third, you see the figures. Both the body and fluid moving with certain velocities. Fluid is also moving. Here you can see fluid is also moving in the different directions, that is air, and aircraft is also moving in one particular direction, of course. Here water is flowing and man is swimming. Means body is also moving, fluid is also moving. This case you see, air is all around flowing and body is also moving, that is car, in one particular direction. Car is also moving. You can see car is also moving and air is also moving. Both the fluid and the object moves with same or different velocities, of course. It is not necessary that both should move with the same velocity. Who knows at what speed the wind is blowing and at what speed the aircraft is moving, right? Next, basics of submerged bodies. If you see the basic Reynolds number, because the ideal fluid and real fluid, depending upon the type of fluid. In case of ideal fluid, viscosity is absent. In real fluid, viscosity is present. Because of that, the drag force and drag force component will affect or will vary with respect to Reynolds number. It is nothing but inertia force divided by viscous forces, rho v d divided by mu. Rho is mass density of fluid, v is uniform velocity, d is diameter or length, and mu is viscosity. Now you see here, u or v is the uniform velocity with which the fluid is moving, and there is a flat plate which is kept parallel, to the fluid. This is length L as it is shown in the figure. Thereby the viscous effects is important here. In this case, the viscous effect is more important. Velocity V, characteristic dimension, density, viscosity, whatever I said. Therefore, Reynolds number is given by rho u L by mu. This L is equivalent to D. For infinite length, Re is equal to rho u x by mu. This is laminar flow situation. This is laminar flow condition. This is turbulent. When the flow direction is straight, indicates laminar flow. When there is wavy movement of the fluid, then it is represented as turbulent flow. Okay. Next. Yes. Boundary layer. When fluid flows past an immersed body, a thin boundary layer will be developed near the solid body due to the no slip condition. That is, fluid is stuck to the solid boundary. Second point, the flow can be treated as inviscid flow outside of this boundary layer, while viscous effects are important inside of this boundary layer. The flow can be treated as inviscid flow outside of this boundary layer, while viscous effects are important inside this boundary layer. You can see the figure here. Here it is, laminar boundary layer, turbulent region. These are all depending upon the Reynolds value. As the Reynolds value increases, the fluid will change from laminar boundary to turbulent boundary layer. This is actually turbulent boundary layer. This is layer 1, this is layer 2, this is layer 3, 4. You can see. So this figure is available in Fluid Mechanics by R.K. Rajput. Dimensional analysis. Dimensional analysis is a mathematical technique which makes use of the study of the dimensions for solving several engineering problems. It is based on the principle of dimensional homogeneity and uses the dimensions of relevant variables affecting the phenomenon. For example, length. How you will analyze with the dimension? What is the dimension for length? It is denoted by L. Velocity, meters per second. What is the dimension for meter? Meter means it is measured in horizontal or vertical direction, length or height. So here it is length, the distance travelled by a car, say 60 kilometer per hour. That means time, t. So L multiplied by t to the power of minus 1 is nothing but the dimensional analysis of velocity or speed of a car or a bicycle. The various physical quantities used in fluid phenomenon can be expressed in terms of fundamental quantities or primary quantities. Various physical quantities used in fluid phenomenon like depth, length, velocity, time, etc., can be expressed in terms of fundamental quantities or primary quantities, as just now I have explained with an example for velocity. Thank you. We will continue in the next class.